Hello guys, this is Physics and today we are going to be talking about heat transfer. Now before we can talk about heat transfer, you need to know what heat is. So heat is a form of energy that flows from a hot object to a cold object. I mean, that's the only way you can explain heat. That's the only way you can describe what heat is. It flows from an object of a particular temperature to another object of a lower temperature. And heat transfer depends on two things. The amount of heat an object can either gain or lose depends on two things, which are heat capacity. And in my previous class I told you people what heat capacity is. Heat capacity is the amount of heat energy that can change the temperature of an object. The heat that changes the temperature of an object, that is heat capacity. So another thing that heat transfer depends on is temperature difference. I mean, heat cannot flow if there is no temperature difference. Yes, the reason why when you put your spoon inside your tea cup, hot tea, the spoon becomes hot is because the tea is hotter than the spoon, and that is temperature difference. So if you want to know the amount of energy that moves from your tea, the amount of heat that flows from your tea to your spoon is going to be a product of these two things. You understand? The heat energy gain or loss is going to be equal to heat capacity times temperature difference. Now, while heat transfer depends on heat capacity and temperature difference, heat capacity itself depends on two things too. You understand? It depends on mass of the objects. You understand? That is either losing or gaining heat. Is that okay? Then it also depends on the specific heat capacity of the object that is either gaining or losing heat. Remember, I told you guys what specific heat capacity is. You understand? I told you that it is the amount of heat that is required to change the temperature of 1 kg of an object. You understand? So heat capacity is going to be a product of these two, mass and specific heat capacity. And then you have the second equation. So looking at this now, you can write this first equation like this, equal to, instead of writing heat capacity, you can write MC, and then you write your change in temperature or temperature difference. So you cannot really talk about heat transfer without talking about law of conservation of energy. Yes, law of conservation of energy. It says that energy can neither be created nor be destroyed, but it changes from one form to another. You understand? You cannot create energy, you cannot destroy energy. It's just that energy has many forms. You understand? And all these forms are interconvertible. Like they can, if a particular form can change and become another form. Just take for instance, if you want to boil water now with electric heater. You understand? Now the electric heater uses what we call electric energy. This is the electric energy. You understand? Now that electric energy is going to be converted to heat energy that is going to warm the water for you. You understand? The electric energy is going to be converted to the heat energy that will heat the water and warm it for you. So you can now say that electrical energy, you understand, is equal to heat energy. That is according to the law of conservation of energy. Now this is also electric energy equal to heat energy. You understand? You can also write electric energy like this, and it is equal to heat energy. You understand? So here in this diagram, letter I means electric current. Electric current. You understand? Then letter V means voltage. Electric current that passes through the heater, and then voltage of the heater. You understand? Or you call it potential difference. If you don't want to call it voltage, you can call it potential difference. And then letter T means time. Letter T means time, just time of flow of current, the time it took the current to flow. And then you have letter P here. Now this P is a product of current and voltage. P here is power, electrical power. You understand? Electrical power, and it is a product of current and voltage. And then finally you have resistance, electrical resistance. So let me know what you think in the comment section. In my next class, I'm going to solve calculations based on this. Thank you for your audience. Bye.